Have you ever really stopped to think about what happens after you take a bite of food? I mean, really think about it. It's not just about feeling full. It's the kickoff to an absolutely incredible journey through a complex biological factory that's hidden right inside you. So let's follow that journey, from the very first bite to the very end.
And just how long is this journey we're talking about? Well, get this. If you were to stretch out the entire pathway from end to end, it would be, on average, a staggering 9 meters long. That's right, 9 meters. That's about the height of a 3-story building, all expertly coiled up inside your abdomen.
Now, this entire pathway has a name, the alimentary canal. You might also hear it called the gastrointestinal, or GI, tract. But really, you can just think of it as one long, continuous tube with some really crucial stops along the way. This is basically going to be our map for the whole trip.
So what is the main mission of this 9-meter-long factory? Well, it's all about deconstruction and conversion. It's about taking that sandwich or apple you ate and turning it into the fundamental energy and building blocks your body absolutely needs to survive and, thrive.
This whole factory basically runs on a 7-step assembly line. It all starts with ingestion. That's just getting the food in. Then you've got propulsion, which moves everything along. Mechanical and chemical breakdown, that's the heavy machinery, smashing and dissolving the food. Secretion adds all the essential chemicals to the mix. Absorption is the key step where we pull out all the good stuff. And finally, excretion, well, that takes care of the leftovers.
Okay, so our journey starts right at the front door, the mouth. And make no mistake, the real work begins immediately. It happens long before your food ever even gets close to your stomach.
And right away, 2 different kinds of digestion kick into gear. First, there's mechanical digestion. This is the physical stuff, the crushing, the grinding, the churning. Then, at the same time, there's chemical digestion, which uses specialized molecules like enzymes and acids to take food apart on a molecular level.
And your mouth, it turns out, is perfectly designed to handle both. Your teeth, of course, take care of the mechanical side of things with chewing. Meanwhile, your salivary glands are already launching the first chemical attack.
This chemical attack is led by our very first enzyme, salivary amylase. Now, a great way to think of enzymes is like tiny molecular scissors. And this specific pair of scissors in your saliva immediately gets to work snipping apart complex carbohydrates into simpler sugars, right there as you're chewing. Pretty cool, right?
So once you swallow, the food doesn't just fall down into your stomach thanks to gravity. No, it's actually actively pushed down by muscular contractions through the esophagus. This 25-centimeter tube travels down your chest, passes the diaphragm, and delivers that food to the next major station. And what is that next station? Well, it's the stomach, a powerful, muscular sac that's designed for some of the most intense phases of digestion. This is where things get serious.
So let's zoom in from our main map and focus just on the stomach. And you really need to forget any idea of it being just a passive bag that holds food. This organ is an incredibly dynamic and powerful piece of machinery.
The stomach's incredible power comes from its unique muscular structure. See, most of the digestive tract has 2 layers of muscle. The stomach, it's special. It has a 3rd layer, the oblique layer. All 3 of these layers work together, allowing the stomach to churn, twist, and pummel food from every possible angle. It's a total mechanical beatdown.
While all that churning is happening, the stomach also unleashes a seriously potent chemical attack. It floods the area with gastric acid, creating a super acidic environment. This, in turn, activates a powerful enzyme called pepsin. This acid and enzyme duo specifically goes after proteins, starting to unravel their complex structures. So after the stomach's intense workout, the food is now this thick paste called chyme. And from here, it moves into what is, arguably, the most important section of the entire system, the main absorption zone. And this brings us to the small intestine. This is where the final little bits of chemical digestion happen, but more importantly, it's where nearly all of the nutrient absorption takes place. If this whole system has a superhero, you are looking at it.
But hey, even a hero needs some trusty sidekicks, right? Well, the liver produces something called bile, which the gallbladder stores and concentrates. Bile works like a detergent, breaking up big globs of fat. At the same time, the pancreas sends in a powerful cocktail of enzymes to finish dismantling everything. Carbs, proteins, fats, you name it.
So you might be wondering, How does this whole system manage to move, secrete chemicals, and absorb nutrients all at the same time? Well, the answer is in its fundamental structure. To really get it, we need to zoom way in, past the organs, and look at the actual layers of tissue that make up the entire canal. So the entire tract is built with 4 layers. On the very inside, you have the mucosa. This is the layer that actually touches the food and absorbs the nutrients. Next up is the submucosa, which is kind of like the wiring and plumbing, holding all the blood vessels and nerves. Then you've got the muscularis, which is the engine, the muscles that propel everything forward. And finally, on the outside is the serosa, a protective, slippery wrapper that keeps everything running smoothly.
Now this brings us to the real secret behind the small intestine's incredible efficiency. Its inner wall isn't smooth like a pipe. Nope. Instead, it's covered in millions and millions of tiny finger-like folds called villi. And if you zoom in even closer, each of those villi is covered in even tinier projections called microvilli.
So why? Why are these folds within folds? It's all about maximizing surface area. It's an absolutely brilliant design. Altogether, the villi and microvilli increase the absorptive area of your intestine to about the size of a tennis court. A whole tennis court! This massive surface ensures that as the chyme passes by, there's every possible opportunity to capture every last nutrient.
Okay, so once all the good stuff has been absorbed, whatever is left of our meal moves into the final leg of its 9-meter journey. We're almost at the end of the line.
The large intestine's main jobs are pretty straightforward. It needs to absorb most of the remaining water along with some vitamins and ions. There's no major digestion happening here anymore, just processing. It basically takes all the leftover indigestible material and compacts it into what will eventually become waste.
This compacted waste gets stored in the rectum, and then it's finally eliminated through the anus. This final exit is controlled by 2 muscular rings, or sphincters. One is involuntary and one is voluntary. And their action marks the final step, completing this incredible 9-meter journey. So think about it. From that very first bite to the final exit, this complex 9-meter factory has been working tirelessly 24/7 just to fuel your body. It's a truly remarkable system. And that really only leaves one question, doesn't it? What kind of raw materials are you choosing to feed it?